Hello friends, today I am going to start with the mathematics book of the class 11th, and we will start chapter number 5, which is complex number and quadratic equation. So let me write down the topic name first. Complex number and quadratic equation. Before starting the chapter, we should know what is the form of the quadratic equation. Why do we need this complex number? Okay, so first start with the equation x square plus 1, and we know that there is no real solution of this equation because this equation is equal to x square equals to minus 1, so we can't have real solution of this equation. So what we do, we have to extend the real numbers so we can write down the real solution of this equation. Or in other terms, we can say, let's we have a quadratic equation which is like ax square plus bx plus c. Now, when will be the real solution exist for this equation? So first thing, we calculate the d, which is simply equals to b square minus 4ac square root. Okay. Now, on the basis of sign of d, we tells that if actually you can write this way, or you can say that b square minus 4ac is equals to 0. It can be greater than 0 and it can be less than 0. So less than 0 and it can be greater than 0. Okay, in the three cases, when you have this case, then you say that solution of this equation are real and both equal. Okay, real root, I am denoting here solution by root, real roots and equal. Okay, in this case you have no real solution, and in this case you have real and distinct root. Okay, now we are talking about this second case where the root are not possible, so real root are not possible this equation. Then what we do, we extend the real number and we define a complex number. So right now I am starting with the complex number. So how do you define the complex number? So complex number is denoted by the simply z, and we define a symbol which is equal to minus 1 of square root of minus 1, which is equals to iota, and when you square, then this number is simply equals to minus 1. Now from equation, let's denote this equation 1 and this equation 2. Now by comparing both equation, you can easily tell that this x square is equals to minus of iota square, sorry, iota square plus. Okay, so this x will be equals to plus minus iota. So this is the solution of equation x square plus 1 in the complex number form. Now we have said that complex number z is denoted by a plus iota b, where a and b are the real number, a and b are real number. Okay, so these number can be anything, so like a can be 5 or whatever number the real number, and b similarly 1 2, and it can be also in the fraction like 1 by 2 1 by 6 like this. Okay, now we have to understand that sometimes this real number, this complex number is written simply real part of the z plus iota and imaginary part of the z. This is also a complex number denoted in this form. अभी देखो यहाँ पे जो real part है वो z का, which is equals to simply by comparison of this equation and this one, you can say real part of z is a, and the complex part, or sorry, imaginary part of this equation is equals to b. Clear? Now you can understand, I am writing down one complex number here in the form of digits. So let's say you have 3 plus iota 4, or you let's say you minus 3 minus or plus 8 iota. So here real part of z is equals to 3 and the imaginary part of z is equals to 4. In this complex number, real part of z is equals to minus 3 and the imaginary part of z is equals to 8. So we have to write with this sign. So here you can't skip this sign, negative sign. Okay. Now how to write down or how to add two complex numbers. So let's say we have now two complex number. Z1 is equals to a plus iota b and Z2 is equals to b or c plus iota d. So when you are adding two complex number Z1 plus Z2, then you can see in the right hand side it will be a plus iota b for Z1, then plus sign, and then Z2 c plus iota d. Now you can see that here real part is a and here real part c. So in the when you are adding to complex numbers, so real part will be get added with the real and complex part you can add with the complex number. Okay, now you get this a plus b here, and in this side you have iota, sorry, this is b plus d and this is c. Oh, so real part is c. Okay, then b plus d. Now you can write down this another notation by here. Let's say a plus c is equals to capital A1 plus iota b plus d is capital A2. That is Z1 plus z. What can you say here? If we uh, uh, take two complex number a plus iota b and c plus iota d, and if we add two complex number, then the addition of two complex number will also be the complex number. So you can see easily this is the real part of that and this is the complex part of that. After that we can start with the comparison of two complex number. Okay, so let's say comparison of two complex number. So you have one complex number which is z1 which is equals to a plus iota b, and second complex number z2 which is equals to c plus iota d. And if we say that the complex number z1 is equals to z2, then the real part of the complex number of z1 should be equal to the real part of the complex number of z2. So a will be equal to c and b will be equals to d. Then these two complex number will be the equal. Okay, now after that we will start with the algebra of the complex number. So let me write down here. Now algebra of complex number, one of the properties I have already written in the previous slide, so which was how to add two complex numbers. So you have one complex number z1 which equals to simply a plus iota b, and z2 which is equals to c plus iota d. When you add two term two complex number, then it will be a plus c which is real part, then with iota symbol b plus d. Clear? So this is the two complex number addition. Now the next, so what are the property which this addition law follow? Okay, so addition of the complex numbers satisfies following properties. So let's start with the first one, which is the closure property. Okay, now what is the closure property? Can you tell me? Okay, so let's start with the first one. Now the closure property of a equation is simply you have a complex number z1 which is equals to a plus iota b. Okay, now you have now the we were doing the closure property of the complex number. So you have one complex number z1 and another complex number which is z2 equals to c plus iota d. And this property I already mentioned, which is if you add two complex number, then the resultant complex number will be also the complex number. Okay, it can't be real number. So additional to that, I'm denoting it by some another complex number which is, let's say, z3. So z3 will be the complex number. Okay, Z3 is complex number. If Z1 and Z2 are complex number. Clear? Next slide. Now this is the first property which addition law of the complex number follow. Second is commutative property or commutative law. Commutative law, similarly here again you have two complex number which Z1 is equals to A plus iota B and Z2 is equals to C plus iota D. Now you add Z1 plus Z2, then you will have A plus C plus iota B plus D. Okay. Now you can add Z2 plus Z1 and then you will have C plus A and plus D plus B. Now you can see this Z1 plus Z2 is equals to Z2 plus Z1, because when you add two real numbers, so like A is equals to 3 and B equals to 5, then addition A plus B will be equals to B plus A. Okay, so 3 plus 5 will be equals to 5 plus 3. So similarly, if this law is followed like Z1 plus Z2 is equals to Z2 plus Z1, then you say this addition of the complex number follow the commutative law. Okay. Now law number 3, which this addition follow, which is associative law. Okay, associative law. In associative law, we have three complex numbers. So like Z1, Z2, and Z3. You can add two pair first, and the left the third one. Then in the second case, you left the one of them, and plus add the second with the third one. Then if complex number follow this law rule, then you will say they are following the associative law. Okay. Now the fourth one is the existence of the additive identity. Now you have fourth law, which is existence of additive identity. Okay, so this is identity. It means like you have a one complex number. Now you add another complex number in this, which doesn't change the original identity of this complex number Z1. So this is the complex number. Let's say this denoted by Z dash, which is simply not right now Z dash, because we will use this symbol again. So let's say this is Z2, which is 0 plus iota 0. Now this is also complex number where real and imaginary part are 0. But if you add this complex number in Z1, which will not change the real identity of the complex number Z1. So if anyone say asking you what is the existence of additive identity for the particular complex number, then you will say this is the additive identity for that complex number or any complex number. Okay. Now the fifth one, which is the last property which this addition of the complex number follow, which is existence of additive inverse. Okay, existence of additive inverse. So you have complex number Z1, which is simply equals to A plus iota B. In additive inverse, what we do, we just change the symbol of this real or imaginary part. So Z is equals to A plus iota B. Then real part of the Z is this one, and the complex or imaginary part of this complex number is this one. Now what we do, we change the sign of this real part, so which is simply equals to real Z ko we multiply by the minus sign. Okay, and then you have minus 1 into A, it is minus A, and imaginary part will be of Z is equals to B into minus 1 equals to minus B. Then you define this new complex number Z2, which is equals to minus A minus iota B, and when you add both complex number, then you get the which is what the identity matrix for the complex number, which is 0 plus iota 0. So this Z2 complex number is called the additive inverse of the Z. Okay, so Z2 is additive inverse of Z. Clear? So now the last, so these were the 4 or 5 property for this addition of the complex number. Now the next one, the final point for today we are going to study is subtraction of two complex number. Okay, subtraction of two complex number. Similar to the addition of the two complex number, you have complex number z1 equals to a plus iota b and z2 equals to c plus iota d. It doesn't matter you are adding to complex number or subtracting. Always remember that you can add the real part with the real part of another complex number, and the imaginary part of the one complex number with the another imaginary part of the other complex number. So z1 minus z2 will be equals to simply a plus iota b, then minus c plus iota d. Okay, so real part of the first complex number this one, and this second complex number is c. So it will be a minus c, then plus this iota in the second number here, and with negative sign here, this d. So I have taken the I common, then you can write down b minus d. Sorry. Okay, this is not the equal sign. Now this will be the subtraction of the two complex numbers. Now the next which comes in your syllabus is multiplication of the two complex number. Okay, multiplication of two complex number which have like a lot of numerical problem. We will solve them, and last one divide of two complex number, division of two complex number, division of two complex number, which we will solve in the next class. Thank you.